Hello again, everyone. My name is still Mickaël Salaün. I will not talk about script execution, but about sandboxing. I would say the common point is about security policies. And so I'm also the kernel maintainer for the Landlock Linux security module. So I'll talk a bit about Landlock, but the main topic of this talk is about a new Landlock configuration format, which is designed to describe security policy for Landlock. So first, sandboxing. Well, to be sure that everyone is on the same, has the same definition. Sandboxing is a way to restrict execution environments to prevent, malicious software from doing not good stuff. Landlock is the unprivileged mechanism provided by the Linux kernel to do sandboxing. So in a nutshell, it is kind of between seccomp and SE Linux or AppArmor. So it is unprivileged. Everyone, every application can use it to restrict access to its own resources. So Landlock is 4 years old now. So it's been in the kernel since the 5.13. It's enabled by default on most distros, and there are some sandboxing tools that are using it. So I guess the most common one is setprev. You can have a --landlock, whatever option with setprev, but there's also minijail or filejail or other stuff that are working on or already using Landlock features. There are also different kind of libraries, for instance in Go, Rust, or even minijail, which is also a C library, or there are kind of a plate implementation for Linux using seccomp and Landlock. But most importantly, I would say, for end users, applications, there are some various kind of applications which are sandbox with Landlock. The good thing is that it's kind of invisible to users. You don't need to know that Landlock is being used because the point is there is no specific configuration tied to these applications. So yeah, you can see, document viewers, package managers, and archive manager tools, or even desktop services. So some Landlock properties, and I would like to start with the main two use cases for Landlock. The first one is to sandbox applications to change the code and to make them request to the kernel to limit themselves, to sandbox themselves. So the idea is that initially the application is trusted, more or less, but at some point. And then it can drop privileges. For instance, if you, by default on Linux, when you launch an application, it has access to all your files, but that obviously might not be needed. And if you just want to view a picture, this picture viewer doesn't need to have access to all your SSH keys, private documents, and company documents, so on. So that's why you can enforce security policy on the kernel object it knows that it needs, but not the other stuff. That's useful for, parsers, which are known to be most of the time difficult to write in a secure way. So that means archive tools, file format conversion, and so on, but also web browsers, because, they are so complex. And everything which is connected to the network that might be reachable by any attackers. So that's the first use case, to update your code, use base code, to make it aware and to secure your users. The second use case is when you don't own the code, when you cannot change it, and for different reasons, you might want to run existing code on a specific environment context. That might mean to run application containers. You might use an init system that launch some services, or you can just launch applications with a wrapper, so that will create a sandbox and launch the application inside this context. This talk is about this second use case, but first I will explain a bit how we can use the first use case and why we needed some new stuff for the second use case. So Landlock can restrict different kind of access to the system. There are some implicit restrictions which are mostly needed to avoid sandbox escape, trivial ones, and some other explicit access rights which are dedicated to enforce your security policy on the system. So that might apply to the file system, to networking, connection binding, or even IPC between different processes. Also, one thing to keep in mind with Landlock is that it's getting new features with new kernel releases. So, for instance, right now we are at the version ABI 7th. And as you can see, with not all, but some new kernel versions, we get new kernel features, new restrictions. And that means, users, developers can improve the security policies as sandboxing features with Landlock. But of course, that means we need to be careful about compatibility. For existing sandboxing application to not break with a kernel update, of course. So, how does it work? In theory, it's quite simple. The goal of Landlock is to restrict ambient access rights. When you're executing an application as a user, this new process gets all your existing access rights. The idea is to drop some of them according to the kernel semantic, which means, to identify files, network ports, or this kind of stuff. So to use Landlock as developer, you have 3 dedicated syscalls. You can create a rule set, populate a rule set, and then enforce the rule set on the calling thread. Once the policy is enforced, is it inherited to all future children. Otherwise, it will be easy to escape this sandbox. And once it is enforced, you cannot remove these restrictions. So let's see how we use Landlock in C or in Rust, for instance. I will not talk too much about compatibility, but there's a simple mechanism which is useful to know which set of features are supported by the running kernel. And then, there are some some way to easily just request what is supported. So, as I said, first you need to create a rule set. At the left, you can see the C code. At the right, the Rust code. So the Rust code is much simpler to use. Less verbose, let's say. So we define what will be handled, so what will be denied by default, and then you create a rule set. A rule set is in fact a file descriptor. Then with this file descriptor, you can call another syscall, which is Landlock add rule. You pass this file descriptor, and then you define your rule with a define struct that say, for instance, I want for a hierarchy to be able to execute anything beneath it. So you add all your rules, and at the end, you can restrict the current thread to enforce these restrictions. So C code at the left, some part of C code, and full part of the Rust code at the right. That's cool. That works. But it needs, developing some code. So the second use case is about using Landlock without changing the code. And for that, we need a new configuration format, a way to describe security policy with just text files. So there are different use cases. For developer, again, they can and that might want to use kind of configuration format to define the security policy. For instance, if they have some generic or common security policies they want to share between different parts of the software, or just to review security policy for different reasons. Sysadmin, for instance, they might want to execute a lot of scripts they might write themselves or not, but in a restricted environment to make sure, there are no side effects on the system and they don't remove stuff that they should not remove by mistake. So, they might want to launch these scripts inside the sandbox. And finally, end users might want to launch application, programs, scripts, whatever they want, but without too much privileges, without the ability to access the right document, their SSH keys, GPT keys, or whatever they want to protect. So there are we implemented two complementary formats, both kind of similar, but with different properties, JSON and TOML. JSON because, it is a well-known standard and is already used by different kind of configuration file formats. So it's easy to include into other configuration as well. For instance, container configuration. But also because it is flexible and easy to tweak, let's say. That might be useful to dynamically create configuration with a lot of flexibility required. But JSON is not user-friendly, so we also support TOML, which is kind of a INI format, really simple format with key value, and also support commands, which is good if you want to explain why you're enforcing this kind of security policy. Okay, so now let's take a look at what it might look like. So here the JSON format of a simple configuration. So the main part here is to define a set of access rights, which is in this case to be allowed to read and execute a set of file hierarchies defined here. So this is kind of hard-coded into the file format, the file configuration file. But you might also want to have some kind of more flexibility to be able to not change too often configuration files, or even inherit some variables from other files. So you can define variables, simple ones, with a set of values, and that can be used with this template format. So it's pretty simple, but so in this case, it is really a raw string. So /home/user/tmp. There's no magic in this user. So that's hard-coded. So it works for a user called user, but not for user called John. That's why variables might be useful. JSON, you like it or not. But if you don't, you can write the same configuration with TOML, which is, easier to understand, I guess, and to write. So that's the same thing. You define, in this case, a variable called RW with a set of hard-coded path, in this case. And you can use it here, or you could use it here as well. Because I was asked about static path here in home user. One key point that we talk in a few slides is to be able to compose different files. So for instance, you have one which contains these two sections and the other that contains only variables. So which kind of property do you want with this file format? Well, we want to be able to share some security policy, some part of it, some snippets, because that might be useful to users, and we might want to, work together and get useful security policies built in something that, might help everyone. But also, we want to make it easy to maintain, so it needs to have a good compatibility history. As we saw before, the kernel is getting more and more Landlock's version of time, so this file format needs to be flexible enough to still work with older kernel or newer kernel. The file format is declarative and deterministic, so it doesn't matter if you define a variable before or after it is used, it will do the same every time. And it is customizable, thanks to variable mostly. But also, if you want to have more flexibility, you could use a JSON format. And for instance, with tools like JQ, you can add or remove some parts of a set of files. Shared policies. That's a difficult point to achieve in practice. There are some requirements. So the idea is really to be able to have standalone snippets, so some parts, some subset of security policies to be tailored to some programs, but to have the generic part in one side and the custom part in the other side. So if we can just use variable, that's good. Otherwise, you might want to split files to give more flexibility to end users. Another important point to keep in mind is that we may want to use different sources. So the different configuration files might come from different people, different organizations, different communities. They might come from the upstream developers that might ship default configuration with their application. But also these developers might want to either take these configuration files directly or add their own if the upstream doesn't provide them. And sysadmin or local users might also want to customize some part of security because they have some specific path and they have some specific use cases. So for this to work, we need to have a good policy composition story. So as I said, there is backward and forward compatibility, and we need to be careful about that. And another thing to keep in mind is that by default, so it's not simple when you use it. It might not be simple when you read it, but you need to define a set of handled access rights, which are denied by default. And on this denied access right, you need to add exemptions, which are called rules, to allow access to some files in read, write, and so on. But the basic idea is that it is a denied by default security system. So if a configuration file that supports Landlock version 4 and another configuration file that supports Landlock version 5, if both are composed together to make sure that the end result will work, because the first file was tested and the second was tested too, but both were not tested together, then we need to lower down and to remove some access rights which are not supported by, in this case, the version 4. So we'll see an example with that. About the customization, the main idea is to use variables, so that's not something new. But what might be a bit interesting is, as we saw in the example, variables contain a set of values, not only one, but a set of values. And this is, first it might be useful because you might want to extend one pass to several paths at the same time. So this might be handy, but also because if you want to have commutativity and if you want to have deterministic compositions between different files, you cannot have order in variable definitions because, well, you don't know, and you don't want to enforce any order to have priority on one value over the other. And that also means that variable and, well, values can be empty, and that's okay. That means, for instance, if with an update, a configuration file that previously contained a variable and now doesn't contain this variable, if this file disappears for whatever reason, the whole configuration will still create something that makes sense, but without these values. Also, to make it easy, because Landlock has like thousands of access rights, well, there are some predefined access right groups, the most useful ones, which are for the file system read execute and read write, and the whole for, well, to support or restrict everything. So I'm talking about composition, snippets, different set of files. Really the idea, the goal here is to be able to have a lot of different snippets, well, a lot, good enough to make it easy to manage, but to stick to the unit of update. So if you have, let's say, if you install one program that requires 2 packages, you might want to split your security policy, well, in 2 to get one security policy for each package. That might also apply if you want to, well, if you're using some kind of plugins, some kind of extension, well, flexible software architecture. And of course, because end user can provide their own snippets, well, they need to be able to define their own values, and that is really useful because, well, that's flexible. So let's see with something concrete how we can compose 2 configuration files. So these are 2 TOML configuration files. At the left, called snippet 1, at the right, snippet 2. So at the left, so define 2 variables. This one is pretty generic. So it could be provided, for instance, by the system. And the one at the right could be provided by the end user. So what might be common to the all user from the system is what is executable, what should be executable on the system. So you can define, well, a set of hierarchies here. And then, well, we define the common temporary directories that should be writable, but not executable. And so this is defined with this variable. At the right, so let's say it is your own security file that compose with the system one. You can also define the same variable with your own values, in this case, and that will compose and create a set of 3 values, TMP, var TMP, and home user TMP. In this case, you also want to add your own read execute hierarchy for your own scripts, for instance. And it looks like this group of access rights matches, well, almost matches this one, except the difference in the version. And because Landlock is a deniability for access rights, and in this case, we define read, execute, and write permissions. It means that it will infer that the whole sandbox will deny by default read, execute, and write. But in this case, because we only add a rule with a read, execute permissions, it will only deny by default read and execute. So if you want to also deny write, you need to specify that as well. So that's the way it is done. So you can see that all these key names here are really close to the kernel interface. So that was also one goal, to not diverge too much. That means even if the kernel interface evolves, the convention can also evolve with it more easily. So if you want to compose these two configurations, that will be the end result. So before composition, after composition. So this file is not written, but that's the one which is really in memory of the Landlock config library. So what changed here is the version of Landlock which is supported, because, at the right we have the version 4 and the left version 5. So if this one was tested, we should ensure that it still works even with the composition of this one. So because we are only adding new allowed stuff, we should not drop access rights which were not tested with this configuration file. So in this case, the user just didn't update to the latest version, but that might not be a bad thing, because when you want to to update your security policy, you want to test it first to make sure it works. So that's why we are kind of downgrading to the version which is tested, v4 in this case. We're also adding a new path here because we got the v4 read execute permission, which is same as this one. So we are merging this path together. And finally, we're extending the RW variable, so which contains TMP, var TMP, and home user TMP. So we're getting that here while updating the access rights here. So this is the compose file. And this means we can compose as many files as we want, and we'll get deterministic result each time. So it's really useful to split a question in different files, even if they are all updated at the same time. That might be useful and easier to maintain, but also that might be easier for end users or sysadmin to update or tweak or change some file or some content of the file, some variable only. Right now, this library is written in Rust with a lot of tests, but there's also a shared object library target, so there's also a C binding with native C interface to make it easy to use, with a C program, but also with any other high-level languages. There's a JSON schema, so it is well-defined, at least the JSON part, and because same test and same parsing is used for to create and to validate the JSON and TOML formats. This schema is also indirectly used for TOML description as well. But some stuff cannot be described in the schema, for instance, variable templates, because these are only strings. So we have more tests to check these specific things. So you can try it. It's a work in progress, but everything that I talk about is already implemented. So it's available on the Landlock LSM GitHub organization. There's an example which is available here. So, that's the way you can run Rust example, but at the end it creates a full health binary, so you can use it in a simple way. But you can just pass JSON files or TOML file or both of them, and how many you want. And then just pass a binary and it will execute, this command and in the sandbox, which is configured with these files. So the idea is to make this library useful for standalone tools like sandbox tools. I'm working on that too, to have a standalone and simple sandboxing tool to use. But but also to make it useful and usable with other software. For instance, your favorite in system could use this kind of configuration files to launch a service inside the sandbox without additional tools. And also, we're also working with OCI runtime specification to extend it and include as much as possible as what is done here to make it useful and usable with container configurations as well. So there are a lot of potential, and yeah, it's only the beginning, but still it's working, and yeah, I encourage you to test it and give feedback. More generally, you're welcome to contribute to this library, to suggest new ideas, but also to the kernel, to add new kernel features, new Landlock features, to extend the Rust Go library. Well, there are other resources available too. Yeah, if you're more fond into finding security issues, please take a look too. And if you want to sandbox your applications, feel free to do it. You might find some motivation here. And yeah, that's it. Thank you.
Questions?
And if you have any question or not, you might want to also get a sticker.
Additional motivation.
Have you considered putting any sort of minimum bound on the permissions when you're combining the two files? And in your example, you had, say, a sandbox configuration specified by the system administrator for the system, and then the user had their own. And the users, interestingly enough, was specifying a lower version of the policy, and that was effectively overriding what the system administrator had specified. I mean, we could envision where that would presumably weaken the sandbox specified by the system administrator. So I was wondering if you've given any thought, like I said, in this case, snippet 1, the system administrator file specifying kind of like a lower bound, say like we're not going to accept user configuration files that attempt to do this permission lower than, say, v3 or something.
Yeah. So yeah, one thing I didn't talk about is how and who decide this, how these snippets are composed. So, so the idea is, so right now on the configuration, well, the example sandboxer tool, you specify which file you want to use. So, well, that's simple. And if you want to use an existing file, you can use it. Otherwise, you can copy it and change it. There is no way to reduce the access rights from a specific file. You need to, well, copy it and create a new one. And that's also one reason why the idea is to encourage to create different snippets that have small part of security policies, and also to use variables. In this case, well, if you identify that, well, there are a lot of paths here, and I might not want to add all these paths, well, please ask your loved sysadmin to just use a variable instead. And in this case, well, you might have default variable configuration which is provided by sysadmin, and then let's say this part in one file, and this part in another file, and just use import this file without the default variable configuration, but you define your own in your own file. That's the idea. So the idea is to make it simple and as compatible as possible with, well, by taking into account software updates. So yeah, you cannot shrink configurations automatically, but if you want to have this kind of, well, by default, I mean, with provided features with this language, but if you want to have this kind of control, you could also use a JSON version, use tools like GQ, and dynamically or not parse and update your configuration files. So, yeah. And Yeah, so one thing I didn't talk about because it is not implemented yet, but about composition, the idea is to make it easy to use, to group this configuration together. So the idea is to just put all the files into a directory and to sort this directory. And this directory can contain either regular files or symlinks to your sysadmin, distro, or upstream developers that may want to share some snippet of the configuration. So easy to understand for anyone.
All right, if I may. Do you have any indication what the performance impact is? I mean, I'm tempted to use this everywhere. I think that's a lot of checks at runtime done.
So performance impact of what exactly?
The execution time. Initially, I have a overhead of setting this up when starting, any application. And then at runtime, I guess, every file system access is impacted by that. Is that correct?
Oh, well, if you have another check, yeah, of course, there's an impact. So I guess you're talking about the impact of using Landlock. So
yes.
Yeah, there's an impact of using Landlock, using Apamor, SLinux, SciComp, everything. Right now, to give you an idea, so we are working to improve, the performance impact, to make it better about using Landlock, but right now it is still pretty good. I mean, there's not, it's difficult to see overhead. To give you an idea, so here we're talking about micro benchmark. So if you want to benchmark, let's say, the OpenSyscall, which might be impacted by Landlock access control on the file system, I think the impact might be around something like 10%, but it might be, in fact, between, let's say, 5 and 15. It depends on different things. But what should matter is really the impact on the whole execution of a context of application. And if you take a look at the time an OpenSyscall takes for your most programs, it's nothing. So the impact of Landlock in most use cases, like every other access control system, I would say, is negligible. If you're running like find, sandboxed, I mean, if you're like walking through all the files on your system, yes, you'll see an impact, of course, with everything. But in this case, yeah, is it worth it to sandbox this part or not? What is your main priority?
I guess my use case is rather a desktop application, so there it is negligible. Sandboxing find, I guess, doesn't really make sense. Yeah, so I guess that answers my question. Thank you.
Other questions?
I believe most applications, they, like a PDF viewer, want to open one file at an arbitrary location and then not be able to read anything else in the file system. I figure probably the paradigm would be that you open, then lock down, and afterwards you're still able to read on your open file descriptor?
Yes. So that's also something we wanted to have, to make it easy to open resources before and lock down as much as possible, while still retaining the resources you still want to have access to. So that's a useful property that might also lead to some file descriptor leaks in some cases. But overall, I think it's a good property and something we want for Linux systems.
Any other questions? Now let's thank our speaker.
Thank you.